So I will start. So thank you first for inviting me to this Analogical Mind seminar and gave me the opportunity to present my work, which is related to my PhD, as you just said. I aim in my PhD to understand how individual can solve new problem, and I will today present the part of the work related to analogical reasoning in problem solving. So when we need to solve a new problem, we need first to represent it in our mind based on the element it is composed, but also our own experiment, our own knowledge. And based on this representation, we can propose several responses that often are incorrect in the case in which the problem needs you to think in another way. So main theory states that we need to restructure the representation of the problem, that is to define in another way the problem, break up with strong but not useful association of ideas, and create new links between concepts. And this restructuring step leads to find the solution and solve the problem. So currently, there are no strong experimental evidence of how the restructuring is involved in problem solving because it's very difficult to quantify this process and it remains elusive. We assume that we can quantify restructuring processes using science network methodology. So science network methodology is a way to build individual semantic network. In a semantic network, you can see you have nodes that represent words in your semantic memory, and the nodes are related to each other with edges that represent the strength of association of the two nodes. And this semantic network allow us to understand how ideas are organized in our semantic memory. And if we repeat it, so the semantic network building during the problem solving process, we can assess how much this organization of semantic memory can change during the problem solving. And we can use some mathematical variables called metrics that reflect the properties of the network. And we showed in an article we wrote currently in extended revision, but available as a preprint, that the change of the organization of semantic network that reflect restructuring and can be quantified by the difference of the metric of the network can predict the fact the subject will solve or not the problem. So there are other ways to solve a problem among many, and one of them is to use analogical reasoning. So when you face a new problem, you can use a familiar situation or already known problem in order to find the solution and solve the problem. So this cognitive process refers more to the analogy transfer abilities. So as all of you may know, analogy is a high-level cognitive function that allows abstract thinking, high-level reasoning, past experiment-based learning. Maybe the most famous analogy is the one between the solar system and the structure of an atom. We can see in both some similarities that are first a stationary element in the center, and then the mobile elements at the periphery, and the same relationship that is one is rotating around the other. And from this analogy, you can extract general rule or abstract rule, or what we call analogy schema. And if you use the analogy schema in an unusual situation or new problem, it can help you to solve this new problem, it can help you to learn new things. And that is the analytical transfer. Currently, there are no strong evidence of how the analogy schema is formed in mind. And we assume that maybe when we did the restructuration of one of the elements of the analogy, so for example, when we restructure the problem of the solar system, so how can the solar system be organized. We need to restructure our mind. And maybe the formation of the analogy schema is related to the restructuring process also. So one of the famous and usual way to explore the transfer by analogy ability is to use the problem-solving approach. And for example, the famous radiation and fortress paradigm. So in this experiment, you ask participants to solve the stomach tumor problem, in which you need to destroy a stomach tumor of a patient. You know that only a kind of ray can be used. The tumor can be destroyed only if the rays reach the tumor all at once at a sufficiently high intensity. But unfortunately, at this intensity, the healthy tissue that the ray passed through on the way will also be destroyed. Or at lower intensities, the rays are not enough efficient. So the question is how to destroy the tumor with the rays without destroying the healthy tissue at the same time. And depending of the study that used the experiment, you have about 10% of solving rates for participants that are totally naive of any of this kind of problem. And there is a second problem, so the fortress problem, in which you want to capture a fortress located in the center of a country with many villages and farms around. There are many roads radiating outward from the fortress. And you know that all have been mined, so that while small groups of men can pass over the road safely, any large force will detonate the mines and destroy villages and farms around. You know that if your entire army could attack the fortress at once, it could be captured. So again, the question is how to capture the fortress without damaging villages and farms around. So the response to this problem is to use a small group of soldiers that will use all the way that converge to the castle in the same time, so that at the end, you will have all your army at the same time in the fortress, and the mine won't be activated. And from this problem, you can extract a general rule, and in this case, a convergence schema. And if you show the fortress problem and its solution before the stomach tumor problem, you will increase the solving rate of the stomach tumor problem. So in this case, you are in spontaneous transfer. So it means that you say nothing more than the stomach tumor. And in this case, individual had to extract and apply the schema themselves. And the solving rate increased to about 20%. And you can be in a directed transfer. So you will specify to the participant that there is a relationship to do between the two problems. So the individual need to only apply the schema himself. And almost, in this case, almost all participants can find the solution. So this is a very strong evidence and demonstration of how the analogy transfer can help in problem solving, and quite robust because it has been replicated in the literature. So as I just said, the problem-solving approach is a very strong way to demonstrate the involvement of analogy transfer in problem solving, but it has some disadvantages. So first, you have as a behavioral output a binary variable, so you can have a correct or incorrect response. You only have one trial because you have one problem, and the thinking phase is quite long. So all these points make the problem-solving approach not suitable, for example, for neuroimaging study to explore the cerebral basis of this cognitive function. In the field of analogy, Emmanuel Vold developed years ago a task, so the analogy task, that aimed to explore the general analogical reasoning abilities of individual. So this task is based on a trial-by-trial approach with several trials and very short response time that allow us to use it in a more to explore the cerebral basis of the analogical abilities. And there is a clear lack of cognitive task approach to specifically explore the analogy transfer. So here is an overview of the project and the three main questions I will ask today, and I want to try to address today. So the first one is, does the transfer by analogy improve problem solving? So we wanted to replicate the radiation and fortress paradigm, but using 4 new riddles. And we want to see if participants will increase their problem-solving ability, whether if they show an analog problem before. Then we wanted to explore the relationship between the restructuring of the initial problem and the analogical transferability. So we want, as we did for the first study, exploring the restructuring processes, we want to quantify the restructuring process during the initial problem, so the problem 1, using the science network methodology. And we want to see if this restructuring can predict the fact the subject will find the solution to the analog problem. We think that the restructuring step can help to extract the analogy schema and so lead to increase analog problem solving abilities. And finally, we developed a new experimental paradigm to specifically explore the analogy transfer abilities. So we use the analogy task already validated in other studies developed by Emmanuel and adapted it in order to create a new task to answer the question whether if we train a participant in a specific analogy rule in a specific domain, if we can facilitate the performance of this individual during the same analogy by applying in a different domain, that is the analogy transfer. So I will show you the material of this new experimental design and show you validation we did. So let's start with the first question. To explore this question, we designed this experiment in which 99 participants had to try to solve 2 riddles one at a time in the first condition. So it means that there are no problem before, no analog problem before. And of course, the 2 problems in the first position had no relationship. During the problem in the first condition, participants had 10 minutes to try to find the solution, and they can give as many responses as they want. After the problem in the first position, participants will have to solve another one. So this new problem will be in an analog condition because participants tried to solve an analog one before. And in this case, participants had also 10 minutes to try to find the solution. But these 10 minutes are divided in 2 parts. So the 5 first minutes is in a spontaneous transfer condition. So we say nothing more than the statement of the problem. And if the participant didn't find the solution after 5 minutes, we gave to them a cue telling them that there is a relationship to do between the actual current problem and the just previous one. And they had 5 additional minutes to try to find the solution, so in a directed transfer condition. As we wanted to have a solving rate for each of the 4 riddles in more naive conditions, so without an analog problem before, we counterbalance the position of the riddle within a couple. And to avoid any training effect or fatigue effect, we also counterbalance the position of the couple of riddles within the design. So you can see here the results. You can see the solving rate for each of the 4 riddle, either in the first condition, so in the naive condition, in red, and in analog condition in blue. And we can see that for the 4 riddle, we have a significantly higher solving rate in the analog condition compared to the first condition. We explore also the average response time, pulling the 4 riddles together. And we can see that the average response time in correct responses in the analog condition were significantly faster than the one in the first condition. So these 2 results showed us that problem solving is improved in the analog condition compared to the first condition. It means that, again, we replicate the result of the radiation fortress paradigm, telling us that the transfer by analogy improves problem solving. I will move on the second question, so about the relationship between the restructuring of the initial problem and the analogical problem solving. So we use the same subject as just before, but what I didn't tell you is that before the problem in the first position, and after the try to solve it, participant did a task called the related judgment task. So for each related judgment task participant did, we can build a semantic network. So I will briefly show you the 3 main steps that allow us to build an individual semantic network. So first, we defined a riddle-specific word list of 20 words that can be related to the problem or the solution, or can be neutral. Then participant did the related judgment task. During this task, participants will see all the word pairs that can be composed using the 20 words of the word list. So 119 in total. And for each of the word pair, they were asked to assess how much they think the 2 words are related to each other using a visual scale. And then we can build an individual semantic network in which the node will be the 20 words of the word list, and the edges will be the strength of association extracted from individual related judgment task. So for each participant, we have 2 problems in the first condition. So we have, for each problem in the first condition, 2 related judgment tasks, so 2 semantic networks. And when we have a semantic network, we can compute metrics that reflect the connectivity properties of the network. In this study, we computed 2 metrics that are mostly used in the science network methodology field. The first one is the agent vector centrality that is related to the nodes. It represents a self-referential measure of centrality. So the more the agent vector centrality will increase in a node, the more this node will be central, important, and influent in the network. The second metric is the efficiency. So efficiency is related to the edges. It represents the degree to which information can be efficiently exchanged between 2 nodes. So the more the efficiency will increase in an edge, the more it means that this age is really important and exchange a lot of information in the network. So if we summarize the experimental design, for each participant and each couple of riddles, we will have this information. So we know if participants solved or not the analog problem. We have two semantic networks, and so we can compute it for each of the semantic network matrix, the matrix I showed you. And we computed the difference between the metric of the second semantic network compared to the first one. So for each edges and nodes, we will have a value of delta metric. And we added the information of the impact rating. So I will detail also what is the impact rating. So the impact rating is a variable we extracted from a judgment of 9 external judges. These 9 judges saw the riddle and its solution. And they did an external independent rating. So they saw the old word pair that can be composed with the 20 words of the word list, such as the participant during the related judgment task. But instead of assess how much the two words are related to each other, they had to assess how much helpful or misleading the link between the word of the pair was in solving the riddle. So the impact rating is a continuous variable telling us whether an age or a node is helpful or misleading to solve a problem. So using a mixed model approach, we wanted to see if the interaction of the delta metric and the impact rating for each of the ages or the node, depending of which metric we are exploring, can predict the fact the subject will find a solution to the analog problem. And we find two main results, significant results. The first one is the more you will increase the efficiency in the helpful pair in the second network compared to the first one, the more the probability to solve the analog problem in a spontaneous condition will increase. And in the same way, the more the agent vector centrality will increase in the helpful node in the second semantic network compared to the first one, the more the probability to solve the analog problem in a directed condition will increase. So if we summarize this result, we showed for the first time a relationship between the restructuring of the initial problem and the fact the subject will find a solution to the analog problem. We think that restructuring the initial problem is a way to extract the analogy schema, and the more you restructure, the more the analogy schema is formed and help you to transfer by analogy. The final point I wanted to show you today is the new experimental paradigm we developed to study analogy transfer abilities of individual. So we developed this new task based on the already validated one, so the analogy task developed by Emmanuel Vol. So I will just tell you a few things about this task. So the analogy task is a way to capture analogical reasoning abilities of participants. They are asked to solve successive trials that require analogical reasoning. So you have an example here. Participant had a cue on the left part of the screen. This stimuli is composed by 3 elements that have a relationship between each other. So they follow an analogy rule applying a specific domain. So for example, here, you can see that there is a linear increase in the size. And participants need to choose one of the 2 stimuli on the right part of the screen in which the three elements show the same relationship. So for example, the correct response is this one, because you can find again the linear increase in the size of the element. During this task, participants had to solve several trials using different analogy rules applied in different domains. So it really captured global analogical reasoning ability. They were instructed to be as fast as possible to give their answer, but they had to keep in mind to prioritize the accuracy of their response. So the advantage of this task is that it used different types of stimuli, so letters, numbers, abstract figure, that are presented in a different way, so different color, number, size, pattern. So it allows us to adapt the analogy task in order to create our new task. We create several trials with the same analogy rule applied in the same domain in order to train individuals in this analogy domain couple. And we want to see if it will increase their performance if we only change the domain and keep the same analogy rule, that is the analogy transfer. So here is the new task. The new task is divided in two parts. So the first, the two parts separated by 10 minutes. The first part, in the first part, you can, there are 12 training trials that respect the same analogy rule applied in the same domain. So for example, here, you have a relationship of symmetry applying the size. So the correct response is the upper one. And in the second part, there are 12 transfer trials, which follow the same analogy rule as the training trial, but apply in a new domain the subject never see before. So for example, the rule of symmetry apply in the color, and the correct response is the upper one. So to control the transfer effect, we added in the second part 12 control trials that respect a new analogy rule apply in a new domain, either in a new domain or in the domain of the training trials. So for example, here the rule is a linear increase of the size. So you can see here the circle increasing in size, and the correct response is the upper one. And to counterbalance the number of trials within each part of the task, we added 12 filler trials in the first part that follow an analogy rule and apply in a domain the subject never see in other trials. So all the trials are randomized within each part of the task. And we created several blocks in order to counterbalance the domain between the training trial and the transfer trial. But we counterbalance also the analogy rule of the control trial and the training trial. So at the end, we have 4 blocks. Our main hypothesis is that participants will have better performance in the transfer trial compared to control trial because they train first the analogy rule in the first part of the task. And we can also assume maybe that we can find a difference between the performance of the in the transfer trial compared to the training trial. To go a little bit more in the detail of the task, one trial is divided in 3 steps. So the first step is the queue on set. The queue will appear in the right part of the screen for 2 seconds. And then targets onset. So the two targets will appear in the right part of the screen. And at this moment, participants are allowed to give a response using the arrow on the keyboard. And they have a limited time of 8 seconds. And then we give to them feedback about their response to be sure that there is a learning effect. Using a square, so if the square is green, it means that the response of the participant was correct, but if it's red, it means that the response was incorrect. And for each trial, we record the accuracy and the response time of participants. So we wanted first to validate this task within a first sample. So the sample we use with the 99 subject for the problem-solving approach I showed you previously. We had to exclude participants because of technical issue, misunderstood of the task, and we excluded also 6 outliers based on the accuracy. So at the end, we have 91 subjects analyzed at the end. So you can see here the accuracy for the 3 conditions of interest, so the training, the transfer, and the control trial. And we found that the accuracy was significantly higher for the training trial and the transfer trial compared to the control trial. We didn't find differences between training trial and transfer trial in terms of accuracy. We can also have a look to the average response time, and we found a similar pattern of results. We found that the average response time was significantly faster for the training trial and transfer trial compared to the control trial. But we didn't find significant differences between the training trial and the transfer trial. We explored also the learning curves of the accuracy for each of the 3 conditions of interest, so training, transfer, and control trials. And we found that the learning slope of the transfer trial were significantly more positive than the one for the control trial, meaning that the learning effect was significantly higher for the transfer trial compared to the control trial. And we didn't find other significant differences between the 3 conditions. So for the learning curve, we did some other statistical analysis. So we use the same statistical model I used to expose you the results, the previous results. But in this time, we use the statistical model within each condition. The aim of this approach is only to explore if there is a significant learning effect at the level of the condition, at the level of the condition or the trials. In other words, it's the same as exploring whether the learning slope is significantly different than 0. And we can see that the learning curve of control trials is dashed. It means that the learning slope of the control trials is not significantly different than 0. So we don't have for the control trials a significantly learning effect. Then we can explore the same for the learning curve of the response time for each of the 3 conditions of interest. And we found that there is a significantly more negative learning slope for the training trial and transfer trial compared to the control trial, meaning that the learning effect was significantly higher for the training and transfer trial compared to the control trial. We didn't find significant differences between the learning effect, between the training effect, the training trial and the transfer trial. And as before, the learning curve of the control trials is dashed. It means again that the learning effect within the control trial was not significant, so was not different than 0. So if we summarize this first result, we show that if we train participants in a specific analogy rule applied in a domain, we will improve the ability of the performance of the individual in the same analogy rule, but applied in the other domain compared to control trials. So it means that our task capture a kind of analogy transfer. So we wanted to replicate in a second independent sample our result. So we use a new sample in which participants did the same task, but with only one block. And the period between the two parts of the task was longer. It was 90 minutes long, during which participants did a puzzle, as you can see here. We included 27 subjects, and we had to exclude 2 outliers based on the accuracy. And finally, there are 25 subjects in the analyze. So I will show to you the same figure for the result of the second sample, but I put also the result of the sample 1 to remind you the results and maybe explore more the similarity and differences. So for the sample 2, we found that the accuracy was significantly higher in the transfer condition compared to control, but also compared to train. And we didn't find the significant difference between the train trial and the control trial, as we found in the first sample. We can explore also the average response time. In the second sample, we have the same pattern of results. So we have a significantly faster average response time for the transfer trial compared to control trial, but also compared to training trial. And we didn't find the difference between the training trial and the control trial, as we found in the first sample. We explored also the learning curve of accuracy. And in the sample 2, we didn't find any significant differences between the 3 conditions, maybe due to the sample size, which is much lower than the first sample. But we can see that the learning curve go in the same direction. And also we can notice that the learning effect for the control 2 condition was not significant, was not different than 0, as we found in the first sample. And finally, we explored the learning curve of response time. We found exactly the same pattern of result between the first sample and the second sample. The learning slope was significantly more negative for the training trial and the transfer trial compared to the control trial, meaning that we have a significant learning effect in these 2 conditions compared to control. And we didn't find a difference between the slope of the training trial and transfer trial. We also have a not significant learning effect for the control trials, as we found in the first sample. So again, to summarize, we find the same main result, which is also that if we train an individual in an analogy rule applied in a domain, we will increase his performance in trial that use the same analogy rule, but in a new domain compared to controlled trials. So we replicate the transfer effect in a second and independent sample. So I will try to summarize all the question I tried to address today. So the first conclusion is that the transfer by analogy improves problem solving. We replicated the part of the result about the radiation and fortress problem solving experiments, but using 4 new riddles. And we show that problem solving performance increase in the analog condition compared to the first condition. We also found for the first time a relationship between the restructuring of the initial problem that we can quantify using science network methodology. And based on this quantification of restructuring, we can predict the fact the subject will find a solution to the analog problem. So for us, again, we can interpret this result as a role in the restructuring process in extracting the analogy schema that help individual to analogy transfer. We need further exploration to confirm this first result and maybe more explore the mechanisms associated. And finally, we developed a new experimental paradigm that aimed to explore specifically the analogy transfer abilities. And I presented to you 2 validation of this new material in 2 independent samples. So I try today to explore how analogical reasoning and specifically analogy transfer can help in problem solving using a problem solving approach, which is the most one I think used in the literature. And we showed that analogy improves problem solving abilities. So we replicate the result of the radiation fortress experiment. And we found for the first time that restructuring of initial problem predicts successful solving of an analog one. So using the science network methodology. And I think, as I said, we need maybe further exploration to confirm this result. And in the other hand, we try to develop a more cognitive task approach to capture analogy transfer. I propose today a new experimental paradigm to do that. And this result opened the door to new questions, and particularly the factors that can modulate these processes. We are particularly interested in the sleep effect because we have some experimental evidence that the sleep can improve restructuring using the science network methodology. So we can think that by these improvements, sleep can help to extract the analogy schema and maybe can help to solve analog problem. And maybe the other question is to study the brain correlates of the analogy transfer abilities. So using the new experimental paradigm with using a cognitive task approach, it is much more suitable to neuroimaging study and explore the brain correlates of analogy transfer to see if there are specific brain activation that is related to analogy transfer. So thank you for your attention. I want to thank my two supervisors, of course, Emmanuel and Delphine, and my collaborator, Yoed, but also all the CREA team and DREAM team that helped me a lot in my work, and specifically Alizé, Marcela, and Sarah. Thank you very much.